Is the formula that they give us, is it the same one?
Yeah, I'm going to print that one out. Oh, this lesson. Oh no, I only want to do exam prep. What do you want me to do in this lesson? Have you watched the video?
Yeah.
And you don't like it? You dislike the video?
Yeah, I don't like to. I forgot. I give up this question.
Really? You too?
Yeah. Which one?
Three-force theorem. This lesson from mechanics.
Lammy?
Yeah, Lammy's. Oh, come on. What's wrong with Lammy? Lammy only has one thing in physics. Don't take this away from him. This is all he's done for physics, is Lammy's theorem. Okay, which one do you want me to do?
Anything. I just want
Anything? Okay, I'll do the first one because I've seen that one in the past exams a couple of times. The other ones, I haven't seen them really in past exams, but the first one, is that the one with the weight? Yeah, that one is, I've seen that maybe 3 times in past exams. In fact, I haven't seen the other ones in past exams except maybe just once. I've seen the first one like 3 times recently, but the other ones I've only seen once. Yeah. So, can you read out the info? For example, is it like this? You have a rope, you have a mass, or the mass at the bottom of the rope? Alright, so it's like this.
Yeah.
And how big is this mass now? 5 kilograms. And do I give you anything else?
Yeah. Anger.
Angle. Oh, on the ceiling?
Yeah.
Okay, so do I give you this angle? 50. And I want to know the tensions. Yeah. Okay, who remembers how to do this one now? This is a revision one. Who remembers how to do this?
Yes. Find the anger. Just like sine rule.
It's like the sine rule, isn't it? First we should find all the angles. Well, first let me draw in what we want. We want this tension, and this tension here. And I'll call this one T1, T2, and T3. Yeah. Now, let's find some angles. So I'll just draw that there. Thank you.
You need some.
I do. I also need some graphics, like special effects or something as well. Explosions, yeah. Now, before I start, how do we know we need to use Lammy's theorem here, the three-force theorem? How do I know to use Lammy's three-force theorem? No, listen carefully. How do I know to use Lammy's three-force theorem?
There are 3 forces.
Correct! There are 3 forces here, so we can use Lammy's theorem then. And Lammy said, gave us a formula to relate the tensions and the angles. So I need the angles. If this angle here is 40, then this one here is 40. And because this is 90, then the total angle here is 130. Yeah? Now, if that's 50, this is 50. And if that's 50 and that's 90, then this is 140. And if that's 140 and 130, that's 270, which means this last angle here must be 90. Yeah. So Lammy said that if you take this force here and divide it by the sine of the angle on the other side of it, which is 140, that should equal the other force, which is T2 over sine 130. And that should equal T3 over sine 90. Now, we actually know T3, because T3 is actually the weight. Yeah, 5G. Now this is really good, because I can say this equals this and this equals this. So I can say T1 equals 5G over sine 90 times sine 140, or I could have said T2 equals 5G over sine 90 times sine 130. Sine 90 is 1. So we could actually write this as 5g sine 140, and this one here is 5g sine 130 degrees. And that's the answer once you put into the calculator.
But for the exam, my answer is like 2/3. I changed the 0.5.
Yeah, of course, I'm just being lazy.
Of course.
I am lazy. In the exam you should change this. Yes.
But 3/2 equal
1.5, yeah.
Same.
Yeah.
But I've changed to 1.5.
The physics exams, they always like when students use decimals. It's just tradition in the exam, I don't know. You're right though, it's the same, but they like decimals, so give them decimals. Now, there is another type of Lamy problem, which I'll do, the last one. Can I continue? So, can you just give me the info on the last one? You have the ground, and you have a wall here. And how big is this wall? The height of it?
10 centimeters.
And that's 10 centimeters. And how big is this barrel?
4 centimeters.
This is 4 centimeters?
No, radius is 10.
Radius is 10?
Yeah.
Okay, then what's the wall?
It's 4.
4, okay.
And it's 10 kilograms.
That's 10 kilograms, okay. And 10 centimeters.
Sorry.
Yeah? Now, Lamy's three-force theorem also says that when you have three forces, they should all meet on the diagram. So, do we have three forces here? We do. What we're doing is we're pulling the barrel over the wall, and the barrel is just about moving off the ground. So it's not actually in contact with the ground anymore, just about. Okay? It's on the tipping point. If you can imagine it just tipping. There's a second force, which of course is the weight, which is 10g. But there's a third force, which is the reaction here. And Lamy says when you have three forces, they must meet. So on the diagram, this force, it must meet here, in the center. Now that's really helpful because how big is this distance from here to here? 10. So here to here is 6. And how big is this distance here to here? 10. So if I draw a triangle, this side is 10, this side is 6. Can we know theta?
Yeah.
We can know theta. I'll call this or. What will this side equal? Or cos theta. And this side? Or sine theta. But or sine theta should equal what? 10g. Why? Yeah, Newton's law, first law, that the total force should balance if it's in equilibrium. So the up force should equal the down force. Now, do we know 10g?
Yeah.
Yes. Do we know sine theta? Yes. Can we know or? Yeah. Which is what I asked you to find, wasn't it? Find the or. So my answer is or will equal 10g over sine theta, and theta is theta is sine inverse 6 over 10.
Yeah.
So actually that's kind of handy. I don't even need my calculator. I can cancel these. This will be 981 over 6 newtons, whatever that is. Who needs calculators? 1, 3, 6, 2, 7. Could be 167 newtons.
The problem is to think that point.
Oh, thinking is a problem. Yeah.
But
Nobody likes thinking.
that point.
I know. So
How do you think that?
how do you think that? Students ask me this every year, and the answer is the same. You just need to practice. When you see so many questions, then in future you can see this more clearly. Yeah. It's just a practice thing, that's all. There's no secret.
Is there other ways that you can like solve this other than Lamy?
Yeah, but it's much longer. You have to use turning force. So you would have to pick a turning point and say the clockwise equals the anti-clockwise. Kind of messy, because then you have to start resolving vectors and getting distances. It's not a big deal, but it's not as quick. It's not as quick. Now, funny enough, in the exam, sometimes whoever writes the exam, they give you, the student, a problem that has 3 forces on it, and they actually forget in the marking scheme that you can actually use Lamy, which is good news for you, because they provide a marking scheme that imagines the student did it the harder way. But if you did it the easier way, you still get the full marks. So I think it maybe like 3 years ago there was a problem with a door on the ground, and it had 3 forces on it. It had a weight which wasn't in the centre, because the door was kind of like this shape. So the weight was here. It also had a string holding it to the wall here, and there was a force here. Now in the marking scheme, the way they did that was by calculating all the turning forces and making some equations and then solving the equations. But actually you could have used Lamy, because you know that these should all meet. And this was a lot quicker to do. So the question was given something like 10 marks. But really it should have only been 5 marks if you used Lamy. So it's like you got an extra 5 marks for realising you could have used Lamy, that the person who wrote the exam didn't realise.
This question was 10 marks.
I don't remember. My point was it was overmarked, because the person who wrote the question forgot that you could have used Lamy here. So this is why I actually like Lamy, because it gives you a chance in the exam to gain a couple of marks, because perhaps whoever wrote the exam didn't realise you could use Lamy.
Should the forces be every force opposite side or direction?
What do you mean?
Direction of the forces should be like.
Oh yeah. It doesn't work if the forces are like this. But this object isn't in equilibrium. It's moving then, because there's nothing to cancel it on the other side. So yeah, I understand what you're saying. Should the forces in some way be kind of like spread out, opposite directions? They should. Yeah.
I think sometimes I don't like to use Lamy theory.
No, I don't know. Every year students don't like Lamy. I don't know why.
I like
Why?
it.
Okay.
I like it, but the question is,
Yes.
I can make sure there are only 3 forces.
Okay.
That's the problem.
That's the problem. Okay.
I think is there a hidden force?
A hidden force.
Yeah, hidden force. But I'm not sure.
Okay.
Because of that I can
Go with what feels right. Yes. All right. What's next now? What do we want to see next? Yes.
Page 30.
Exam book.
Yeah.
Page 30.
Version 4.
Yeah.
Section 8.
8.
8.
Like this?
Yeah.
Okay. What is it about? Electricity?
Yeah.
Kirchhoff?
No.
Potential divider?
Capacity.
Capacitor. Okay, go for it. Read it to me, or show me. Aha. A 50 microfarad capacitor is connected in series to a second capacitor of unknown value. 50 micro, X farads. The series is then charged by using 45 volts. So this is 45 volts at the beginning, and then this is discharged through a 10 mega ohm, and it's allowed to discharge. The potential difference across the resistor falls from 45 to 30 in 2 minutes. What did I say this was? 10 mega ohms. Oh yeah, actually I have to text my father back because he tried to call me, so I better do that now.
I guess you know.
Thank you. In class now. Okay. Right, what was I saying? Oh yeah, so we know that after 2 minutes it goes from 45 to 30 in 2 minutes. Right, let's make use of that. So, we know that V equals V0 E minus T over tau. What's the V here?
45.
No, 30. The V0, 45.
Oh, yeah.
The T? The T?
12. 200. 120.
There we go.
Yeah.
Over tau. Yep. Yes?
Yeah.
So, divide by 45, take the log, and that will equal minus 120 over tau. So tau will equal minus 120 over log 30 over 45. What is that, please?
Um, 295.96.
296 seconds. Right, but that's not what they want. What did they ask me for? Oh, wait, that is what they want? What's the time constant?
Yeah.
That's the first question? Sweet. Right, what's the second question then, Kelvin?
Capacitance of the series combination of
The total capacitance for the series. Yeah. Well, no problem, because we can say or C equals 296, yeah? So C equals 296 over 10 mega, that's 10 to the 7. So the answer is 296 times 10 to the minus 7 farads. That's 10 to the minus 6, 10 to the minus 1, 29.6 microfarads. Let me guess the next one. Is the next one, what is the capacitance of the missing capacitor? Yeah. So, what was the capacitance of the first capacitor?
50 micro.
This is 15.
50.
50. And the second one is X. And how do they combine when you add them? What's the rule? 1 over, yeah. So 1 over 50 microfarads plus, now I'll make this X micros. 1 over X should equal 1 over 29.6. So take that over. And then, can someone tell me what these fractions are as a decimal? What's it about, like 0.02 or something?
0.05.
Okay, so then if you then flip this upside down,
Okay.
what you get?
18.6.
Yeah. Is there another part, Kelvin?
Yeah.
What's the next part?
Determine the charge stored on the series combination when the potential difference of socket is 20 volts.
Ah, so boring. Q equals CV. Yes?
Yeah.
Do we know C?
Yes.
Do we know V?
Yeah.
What's the V, did you say, Kelvin?
20.
Oh, so boring, so boring. 18.6 times 2. 18 and 18 is 36. 37.2 times 10 to the minus 5 volts. Is that right?
Yeah.
3.72 microvolts.
No, not 5. 4.
But why is he using 18?
Are you sure?
Yeah. My calculator.
Oh, Stephen, you're so stupid.
No.
Ah, no, it's true. I should have used the total capacitance. I wasn't thinking. What's the total capacitance?
29.
No? What's the total capacitance? Didn't we work it out? The total was 29.6. Yeah. 29.6 micro times 20. Right, 29.6 times 2, 60, 58, 59.2 times 10 to the minus 5 volts.
Not 5.
I keep saying it's not 5.
4.
No, but I'm not finished yet. 5.92. You're confusing me.
Oh, yeah.
Yeah,
You're
you
right,
see, yeah,
you're
no, I
right.
thought so.
You're right.
So divide by, so 592 microvolts.
Yeah.
Yeah.
I don't understand the part where it says the charging source is removed.
Ah, yeah, but so the capacitor can discharge, that's all. Because if you leave the battery in, the capacitor stays fully charged forever.
Oh, I thought it's potential difference being removed.
Ah, no. Right, what's next now? So hang on, Wookie, what was confusing you about this question?
Understand the question.
Okay. The story.
Yeah.
Okay.
Hard.
Yeah, okay. Yes, which one?
Page 27.
What type of question is it?
Electricity.
Okay. That's good, because I was so sick of doing mechanics from yesterday. Page 27.
Version 1, question A4.
Alright, read it to me, Calvin.
A cell provides an EMF of 1.64 volts.
1.6 volts, okay?
1.64.
Okay.
When it is connected across a 5 ohm resistor, the current of 0.3.
Hold on. I assume this cell has internal resistance. Is that what we're looking for? Yeah. Okay, and alright, so what they're doing is they're telling you what the current is at different resistors, is it?
The current is 0.32
0.32 amps. When the resistor is
5 ohms.
and then they change it or they connect another resistor, is it?
The first question is to determine the internal resistance of the cell.
Yeah, we have enough info here because we can use the formula E equals I or plus or, isn't it? So we have 1.64 equals 0.32 5 plus or, right? 1.64 multiply by 10 and divide by 2. 1.6, is it? Oh man. So that's 0.04 over 0.32 is the or, which is 4 over 32, which is 2 over 16, 1 over 12. What's 1 over 12? 0.0 something. Help me out here. What is it?
0.083.
There we go. Okay, I have limits, you know. Right. 0.083 ohms is the first part. Is there a second part you need? Okay.
Because the first part I got 0.125.
Well, I don't know. Is that the right answer?
0.125.
No, it is. Did you look at the marking scheme?
Yeah.
And what?
0.125.
Oh, that's in the marking scheme. So you're saying my answer's wrong here?
Yeah.
Yeah? Did I make any number mistake with my calculations there? Is 0.32 multiplied by 5 1.6?
You got it right when you wrote 0.04 divided by 0.32.
And did they write that in the marking scheme? Like, I'm trying to figure out what the problem is here. Is the problem that my answer and your answer differ to the marking scheme?
No. My answer is same to the marking scheme.
Your answer is the same as the marking scheme. So then why did you ask me?
It's the question 2, the second question.
But you're saying this answer's wrong now.
Oh, the 0.
It's a calculation error.
It's a calculation error.
My calculation error. What was my error? Where did I make the mistake?
It's just equal 4 over the 1 over 1 over 1 over 12.
It's 4 over 32, not 1 over 12? No, it's 1 over 8. Tut. So it should have been 0.125. Okay, I didn't need a calculator for that one. Just the dividing by 4 was all. Right, so what's the second part, Calvin?
When a second resistor is connected in parallel with the 5 ohm resistor, the current through the cell increases to 0.7 amps.
0.7 amps.
Determine the resistance of the second resistor.
Alright, so you've added in a second resistor here. So let's use the formula again. E equals I or plus or. And this time we don't know the or because that's a missing value. 1.64 minus 0.7 times 0.125. Oh, what am I doing? That's stupid. Don't be stupid. 1.64 divided by 0.7 minus 0.125. That's the OR. What's that, please?
2.23.
Now, how do we get the OR if it's in parallel? Well, 1 over OR should equal 1 over x plus 1 over 5. So that means x will equal 1 over 2.23 minus 1 over 5 when you rearrange it. And I'll check my emails while you're doing that. Got an answer, dude? What's the x?
4.03.
Is that the right answer?
Yes. Yes, as a 90. I tried using I tried getting the total resistance of the whole circuit by using 1.64 divided by 0.7.
1.64.
Yeah.
What's 1.64? The voltage divided by 0.7.
I think it's good.
Alright.
And then after getting the total resistance, I tried using the 1 over RT. But then the answer I got is
1 over RT?
Yeah.
What's 1 over RT?
The parallel resistance.
Oh, right.
And then the answer I got is 4.41.
Close. Close.
Okay.
Yeah?
How many numbers should we see from the teacher?
You see, Wookie has asked me that question twice. He asked me that this week, and he asked me it 6 weeks ago.
I know the answer.
He knows the answer. Would you like to tell her the answer, please? Tell her the answer.
You only need 3 significant.
3 significant figures, not 3 decimal. 3 significant figures. You know the difference?
Yes.
Yeah. What do you use in chemistry? 3 significant figures as well?
No, I don't know.
Your teacher doesn't care? It's
I
random.
don't know.
Enough number.
Enough. Okay. Well, that's the same in physics. You can not have too much. You can only have too little. So too little is less than 3. You need at least 3 significant figures. Yeah.
If my answer is 5.21 by 10 to the power of minus 5.
Yeah.
I have changed it like mega something.
No. I just really like to do that.
You don't like.
No.
You like, but it's okay.
It's perfectly okay. I just love using prefixes. It's like my favorite thing to do. Drink coffee, eat cake, use prefixes. Top 3 things. Yeah, that's true. Yeah.
Good.
Oh, no, it is good, yeah.
Good.
My students believe anything. Okay, anything else? No. Anything special going on tomorrow?
Tomorrow?
Oh, is it tomorrow? Yeah.
Special.
Quite interesting.